Students, our next formula is going to be y is equal to 1 upon ax plus b. Now this is a very important formula because we are going to make use of this formula while solving lot of questions. So let's understand what this y equal to 1 upon ax plus b is going to give us. So students, I have this standard function now. As I said, y is equal to 1 upon ax plus b, and I am in need of finding the nth order derivative. That means I want to get yn. So here also I'm going to make use of the same concept of a generalization. I will get first few derivatives, say 3 derivatives, and then by looking at these 3 derivatives I'm going to generalize for the nth order derivative. Now before I proceed with this particular standard form, I'm going to tell you one very important formula. Now do you recall, if I have y is equal to x raised to n, the derivative of y is equal to x raised to n, as we all know, is going to be n x raised to n minus 1, isn't it? The derivative of x raised to n is n x raised to n minus 1. So similarly, if I now ask you to get me the derivative of 1 upon x raised to n. So this is very important. You have to memorize this particular formula as well. As you know, the derivative of y is equal to x raised to n. The similar way, now you need to memorize the derivative of y is equal to 1 upon x raised to n, because again this derivative you are going to make use in lot of questions. So let's find y equal to 1 upon x raised to n. So I can write 1 upon x raised to n as x raised to minus n, isn't it? 1 upon x raised to n can be written as x raised to minus n. And now let's get the derivative. So therefore I can say dy by dx is going to be, it looks like x raised to n. So what is derivative of x raised to n? It is n x raised to n minus 1. So x raised to minus n comes out to be minus n, isn't it? X raised to minus n minus 1. So it is same as x raised to n, n x raised to n minus 1, but we don't have n, we have minus n, so it becomes minus n x raised to minus of n minus 1. So minus n minus 1. Now students, observe this carefully again. Minus n x raised to, can I bring the negative sign common? I can bring the negative sign common here, so I get minus of n plus 1. I've taken out the negative sign common, so you get minus n plus 1. Now students, tell me, what is a raised to minus m? Using the law of indices, a raised to minus m will simply become 1 upon a raised to m, isn't it? So using the law of indices, the negative power in the numerator can go in the denominator and become positive. So here also I can say this x raised to minus of n plus 1 can now be written as, so you get minus n upon, this term will come down in the denominator, you get x raised to n plus 1. So minus of n upon x raised to n plus 1. This is the derivative of 1 upon x raised to n. You now need to memorize it very properly. Look at this, x raised to n. What's the answer? It is n into. So here also dy by dx for 1 upon x raised to n is what? N. It is not into now, it is upon. There is a negative sign, you can observe the difference. Here the power is 1 less than n, isn't it? N minus 1, the power is 1 less than n. Look at this particular formula, it is 1 more than n. So it's a very simple formula, you can remember it very properly. Put a negative sign, you get n, and instead of into, you have to do it divide, isn't it? Upon it is going to come, and the power will increase by 1. There power decreases by 1, here power increases by 1. So you now need to remember this particular formula as well. So therefore, when y is 1 upon x raised to n, I can say dy by dx is going to be minus of n upon x raised to n plus 1. So now the reason of telling this particular formula is I'm going to make use of this particular formula to get the derivative over here also. So this is y, students. I'm going to call this as equation 1. I have y is equal to 1 upon ax plus b. I'm going to differentiate both sides with respect to x. Now you tell me, what is the derivative of 1 upon x? You remember the derivative of 1 upon x is minus 1 upon x square. Very simple formula. Now you can obviously use this particular concept also. Here x raised to n. Look at this. N is 1. Ax plus b raised to. There is no power, isn't it? So the power is taken as 1. So you can put n as 1. If you put n as 1, you get minus 1 x square, same formula, isn't it? But we have the standard formula of 1 upon x, which is minus 1 upon x square. You can make use of it, or you can also make use of this particular derivation that we have learned, the formula that we have learned here. So I'm going to differentiate both sides with respect to x. So I get y1, isn't it? The first order derivative, y1. It is going to be now, so 1 upon x, the derivative is minus 1 upon x square. It is for x. Is this x? It is not x. It is a function of x, isn't it? So I will use the exact same formula as I'm treating for x, but in place of x, I have ax plus b. So I should be differentiating it again using the concept of chain rule, or we say the composite function. So what is derivative of 1 upon x? It is minus 1 upon x square. So ax plus b square into the derivative of ax plus b, which is going to be a, isn't it? So actually I've got my derivative as minus a upon ax plus b, the whole square. But students, I'm going to generalize this particular term. Observe carefully what generalization I'm going to carry out over here. Is it okay to write the negative sign as minus 1? I can certainly write negative sign as minus 1. Is it okay to write it as minus 1 raised to 1? No worries at all. Now you don't worry, at this moment you won't be able to judge how to generalize this. You practice this particular formula 2-3 times, you will definitely be able to recognize how to generalize the terms. And you also have not found the second derivative, isn't it? So once you get the second derivative, then it becomes even more easier to generalize this term. For instance, let's not generalize it at this moment. Let's get y2. So that was y1. So I'm going to get y2 now. So I'm going to differentiate again with respect to x. Differentiate again both end sides with respect to x. So I'm going to differentiate this particular term. I have this minus a upon ax plus b square. So minus and a are both constants. So minus and a are both constants. So I keep them outside. And now I want to find a derivative of 1 upon ax plus b square. 1 upon ax plus b square. Looks like 1 upon x raised to n. Derivative is what? Minus n upon x raised to n plus 1. You have to memorize the formula. This is very important. So 1 upon ax plus b raised to 2 looks like 1 upon x raised to n. So the answer says minus n. So I write minus 1 upon x raised to n minus n upon x, which is ax plus b raised to n plus 1. You have to increase the power by 1, raise the power by 1. So 3, but this is not x, this is ax plus b. So again, I want to get the derivative of ax plus b, which is a, isn't it? Now look at this. How many negative signs have you got? You have got 2 negative signs. Now in general, what one might think that negative into negative becomes positive. But instead of that, is it okay to write minus 1 square? That's why I've written here minus 1 raised to 1. Then observe a into a, that's a square. So here there is only one a, so I write into a. And then observe carefully, students, you have ax plus b raised to 3. So I write here ax plus b the whole cube, and here I've got ax plus b the whole square. And finally, students, observe there is a 2, isn't it? So is it okay to write it as 1 into 2? Here I'll write only 1. So minus 1 square, you get minus 1 raised to 1. Then a square, you have written a. Then 1 into 2, you have written here 1. Ax plus b whole cube, you have written here ax plus b whole square. Let's get one more derivative. Let's get y3 also. So here, instead of differentiating all these terms over here, you can keep this particular term and then differentiate this itself. Okay, so I'm going to differentiate this. So I'm going to get y3 now. So again, differentiate y2 both sides with respect to x. Again, differentiate y2 both sides with respect to x. So you tell me now, if I want to get y3, first to identify all the constant terms. There is -1 square, constant. There is a square, constant. There is 1 into 2, constant. So all these constants, first of all, will be kept aside. So I can say here, -1 square, then a square, then 1 into 2. Every term is a constant. Now observe, I have 1 upon ax plus b cube. Now the numerator is entirely a constant. It has been taken outside, so the space is vacant over there, isn't it? There is 1 now, 1 upon ax plus b whole cube. Again, I can make use of the same formula, 1 upon x raised to n. The formula is n minus n x raised to n plus 1. So here 1 upon ax plus b cube, 1 upon ax plus b cube, you get minus n. So I write here minus 3 upon x raised to n plus 1, you get ax plus b raised to 4. But this is not x, this is ax plus b. So again, I should be writing the derivative of ax plus b, which is a. So now here you have got one more negative term, isn't it? So there were already two negative terms present. I've got one more. So can I say this is going to be -1 cube, then a square into a is going to be a cube, then there is 1 into 2 into this negative sign has gone out, you are now left with 3, that's 1 into 2 into 3 upon ax plus b raised to 4. Now students, tell me, what is n factorial? N factorial is n into n minus 1 and so on, 3 into 2 into 1. So if I ask you to write, say, 4 factorial, will that 4 into 3 into 2 into 1, or is it also 1 into 2 into 3 into 4? Look at this, this is 1. Look at this, this is 1 into 2. So is it 2 factorial? Is this 1 written as 1 factorial? Look at this, 1 into 2 into 3. Is it 3 factorial? So students, observe carefully. When you had y1, you have found the first derivative. You got -1 raised to 1. When y2 is obtained, you get -1 square. When y3 is obtained, you get -1 cube. So now are you in a position to generalize the nth order derivative? You can easily get yn. So I can say in general, yn is going to be -1 raised to n, isn't it? So -1 raised to 1, -1 square, -1 cube. So you get -1 raised to n. Then there is a square, there is a cube. So here you get a raised to n, isn't it? Then you have 1 factorial. Here you have 2 factorial. Here you have 3 factorial. So for n, you are going to get n factorial upon, look at this, this is y1, you get ax plus b square, 1 power more. Y2, you have got ax plus b cube, isn't it? 1 power more. Y3, you have got ax plus b raised to 4, again 1 power more. So for yn, what is going to happen? You are going to get ax plus b raised to n plus 1. So this is the formula for 1 upon ax plus b. This is a very important formula, students. Make sure that you note it down somewhere in your notebook, that if y is 1 upon ax plus b, then I can say yn is going to be -1 raised to n into a raised to n into n factorial upon ax plus b raised to n plus 1. This is, as I said, a very important derivation, a very important formula. The formula is definitely going to get used in solving many of the questions, and sometimes it might also happen that they might ask you to derive this particular standard form. So students, in this particular this thing, we have understood how to find the nth order derivative of y is equal to 1 upon ax plus b, and the formula has come -1 raised to n, a raised to n into n factorial upon ax plus b raised to n plus 1. So students, that was all about this particular standard form. Now let's proceed ahead with the next standard form.